So as I said, I have shown you what each function of these does. So let's get back to this. Now if we uncomment these, so here we will have four different variables. One X for training, 2 for training, and 2 for testing. X for training, Y for training. So we have like the data for training, and then the labels for training. And then here the same thing. We have the data for testing, and then the label for testing. So to do that, to train, we will have to initialize the model. So basically, this is what it does to initialize. But if you want to look, for example, if you want to look up what does that function do, well, I said that I will be treating this function as a black box. So you don't need to know what the details of that function is. But if you want to, then you can go Google up that function, and then you should have the details of all that function inside in a better. I mean, with as you can see here, the parameters that function can take. Some of them are default, so that's why our parentheses are empty, and most of them are in default actually. So all you have to do is basically initialize it, and then train it using the fit function. So and the fit function takes the X train and then the Y train. So basically what you could do is just use this as an idea on how to train a linear model, and forget how this actually works. Once you do it with a couple of examples, then you will try to, I recommend you to go here and try to understand more details about it. And then we have, after we train the model, as I said, we have to test the model. So we don't know the score of this model, we don't know how it works. So for that, the first function we have is linear score. Basically, this function comes with the model itself. It has a function here that is called linear. As you can see here at the end, we have a score function. Basically what it does, it's said here, it computes the coefficient r to the power of 2, is defined as 1 minus u divided by v. So if you want, you could read that up. So it gives you a score between, I believe, between 0 and 1, and that scores will tell you how good is your model. Here, because there are so many ways to understand a score, a certain score doesn't test like all the possible outcomes, so it only tests some of the outcomes. So what we do here, we are going to test our model with different metrics. So here we give, for example, the X test, and it will give us the /y values, so the y values that our model predicted. So not we have these now, we have these, and we have the ones that we predicted. So to do that, we're going to reshape those values because they are not in the shape where I could use. So here we can print the coefficient, and then we can print the score. We will print the score. We will print the variance score, which is the R2 score that we imported here. It is also, if you want to know more details about this, you can just Google it. And it's actually the same score that as the one we did here, which is the score almost similar. Just a slight difference between the two. And then we have the mean square error, which takes y test and results. So, and then finally, to see the difference, well, before that, let's just give it a run to see. And as you can see here, the coefficient is 3, the score is 0.25 out of 1. So basically, it's 25% accuracy. And this is not bad. It's not bad for a model to predict 25% of the people. So as I said, 25% is really not bad to predict the height of any person. So you're basically predicting correctly 25 people out of 100 their height using their weight, or predicting their weight using their height. So as you can see here, we have the variance score, and as I said, they are practically similar. And then we have the mean square error, which is around 100. Now we have a way to actually plot that, to show it as, because not always the numbers are explanatory. So what we do is basically we plot this to make it easier for us to see the values, to see these numbers in a more fashionable way. So if we run this, we will get these nice plot that shows our data and our line in the middle. So this is where basically we're computing the person. So the more height you will be, the more it will think that you're in this category. If you're down there, then it will think this is your height. So basically it's an average, but it's better than an average because we're using two variables to guess the average. So yeah, we're done with this model. So please run this on your computer and try to understand the lines one by one. You can just, if you don't understand any line, you just Google it and read more details about it.